Okay, if you are in 7 Excel, we are working from the Advanced 2 textbook. If you are in Math 8, we are working from the Course 3 textbook. We are doing lesson 2.5, and it can be found on pages 72 and 73. We're going to be talking about similar figures. So before we start with similar figures, I want to review congruent figures. Congruent figures. So we have triangle ABC and triangle DEF. And I am telling you that triangle ABC is congruent. Remember, this is the congruent symbol to triangle DEF. And what does congruent mean? Congruent, same shape, same size. Shape. Here we go. Same shape, same size. And in congruent triangles, congruent figures, corresponding angles are congruent. So angle A is congruent with angle D. Angle B is congruent with angle E. Same size, same shape. Angle C is congruent with angle F. They have the same measurements. And in congruent figures, corresponding sides are congruent. So side AB is congruent to side DE. Side BC is congruent to side EF. And side CA is congruent to side FD. And remember, when we label congruent triangles, we label the vertices in the same order. When we're labeling the sides of congruent triangles, we're labeling the vertices in the same order, okay? So congruent figures, we're talking about same shape, same size. So if they're the same shape and the same size, then corresponding angles are congruent and corresponding sides are congruent as well. Okay? So that's all fine and dandy. Let's talk about similar figures. Similar figures. So we have triangle ABC and triangle DEF. And I am telling you that triangle ABC is similar. This is the symbol for similar. Is similar to triangle DEF. And once again, we labeled corresponding vertices in order. So what does similar mean? Similar means same shape, different size, but that size is proportional. Okay? So corresponding angles. Corresponding angles. Corresponding angles are congruent. They are the same measurement. They have the same measurement. So angle A is congruent to angle D. Angle B is congruent to angle E. And angle C is congruent to angle F. They have the same measurements. Now, where the difference lies is corresponding sides. Corresponding sides are proportional. So AB is similar to DE. They're proportional. Side BC is similar to side EF. And side CA is proportional or similar to side FD. Okay? So congruent figures, same size, same shape, everything, all the corresponding parts are congruent. But in similar figures, same shape, proportional sizes, different sizes, but proportional, our angles are congruent. That means they're the same measurement, but our sides are proportional. They are similar. So what does all of that mean? Well, let's take a look. Now, you guys learned about proportions in 6th grade. And proportions, all proportions are equivalent fractions. So proportions are equivalent fractions. And how do we determine if fractions are equivalent? So we have 1/2 is equal to 5/10. How do we prove that these are equivalent fractions or that they are proportional? We do that funny thing called cross multiplying. 1 times 10 should equal 2 times 5. 1 times 10 is 10. 2 times 5 is 10. This is a true statement. Therefore, 1/2 is equal to 5/10. They are equivalent fractions or proportional. They're equivalent fractions or proportional. And we're going to use this idea. This is exactly what the whole lesson is based on today. The idea of proportions or equivalent fractions. So the book has given us 3 parallelograms. And all 3 parallelograms are different sizes. And we want to know which 2 figures are similar. And we know that similar figures are proportional. So we need to find the corresponding sides. The corresponding sides. So it looks like all 3 of these are corresponding sides. And then it looks like the widths are all corresponding. So we need to figure out which 2 are similar. So I'm going to go with A and B first. So I need similar sides. So the pink, A, the pink, over B pink. Then A yellow over B yellow. These should be equivalent fractions. So let's take a look at the corresponding sides. 8 corresponds to 4, and 12 corresponds to 6. Okay, so we've got corresponding sides. So now let's cross multiply. 8 times 6 should equal 4 times 12 if they are proportional. 48 equals 48. Would you look at that? That is true. Therefore, they are similar figures or proportional. So A and B are similar figures. Now let's take a look at B and C. So we're going to do the same thing. We need corresponding sides. So 4 corresponds to 6. And then here, yellow corresponds to yellow. So 4 is corresponding to 6. And this width, 6, corresponds to this width, 12. So let's cross multiply. 4 times 12 should be equal to 6 times 6 if they are proportional. 48 equals, oh, this is a false statement. Therefore, they are not similar. So A and B are similar. B and C are not similar. Therefore, A and C are not similar. If these are similar and this one is not, then this is not similar with either one. So we're using that idea of equivalent fractions and cross multiplying to determine if figures are similar. Now, using that same idea, we can determine missing parts. We can determine missing parts. So I've got this triangle right here, A, B, C, with a height of 4 and a width of 6. And then I have this triangle right here, D, E, F. And this is 10 and this is X. And I'm telling you, triangle ABC is similar to triangle DEF. I'm telling you, they are similar triangles. So with that information, can we figure out X? Yeah, we can, because similar figures are proportional. So we need to find the corresponding sides. We have the height corresponds to the height, and the width corresponds to the width, okay? So we've got triangle ABC over triangle DEF. So the height over the height should be equal to the width over our unknown. So 4 is a corresponding side to 10, and 6 corresponds with our unknown. So let's cross multiply. 4x, 10 times 6, 4x equals 60. I need to isolate my x, so let's divide by 4. X equals 15. So using the idea of equivalent fractions or proportions, we can figure out that this missing length is 15. So that's everything we're doing today. We are using the idea of equivalent fractions or proportions to determine if figures are similar, or using similar figures to determine missing parts. And it's all based on this idea of proportions and equivalent fractions.